All right. Hey everyone. So today is July 2nd. So everybody's busy with holiday plans. So uh today we're going to be covering the Chapter 8 review. Last time we looked at the Chapter 7 review. Uh so one thing I want to point out is we've finished the midterm and that's great. We're halfway through. We're going to be kind of shifting gears a little bit. So this class we mentioned before, this class is no joke. This is a hard class, and so uh, for those of you who've been coming to the lectures and coming to and getting stuff done on time, you're doing pretty good. Okay, so uh, we're going to be shifting a little bit because previously we were covering a lot of stuff very rapidly. Um, we're going to slow down our pace a little bit, but that's because a lot of the material is a bit harder. Okay. So you'll notice that last time we only did Chapter 7 review. This time we're only doing the Chapter 8 review. Most of the days we're going to be covering one thing, and that's because a lot of the material we're going to be covering now is, getting into topics that can be very confusing. So I want to make sure everybody is clear on everything, and if you have questions, let me know. So it's still difficult, still, but in a different way. Okay. The material's harder, there's less material. Okay. Um, okay. So that said, chapter 8 review today and just the 9.1 lecture notes. We're going to be spreading not chapter 9 out a little bit. So like next time we'll talk about the chapter 9.2 lecture notes. Okay. So chapter 9 is a very difficult chapter. Anyway, all that said, keep going with what you're doing. Everybody's doing well so far. So, if you are in a situation where you are pretty low in terms of your score, now is the time that you might consider if you're like, am I going to be able to pass this course? Okay. Because what we don't want to do is, if you have no shot at passing the course, you stay here and it hurts your GPA. It looks, you get a bad grade on your you know your record. So, uh, if you are considering withdrawing from the class or dropping the class, feel free to reach out to me. I can discuss, what your options are. My very first semester of college, very first semester, I was like, yeah, going to college. I'm going to take 18 credits, and it was too much. And I had one course that I ended up dropping. It was the only course I ever dropped in all of my college career. But I have a W on my transcript, and a lot of people point out that W stands for wisdom. So, because that ended up not hurting my GPA. So,
I had
um,
some wisdom too.
you had some withdrawals, yeah. So, yeah. So there's certainly no shame in withdrawing if that is where you're at. Now, for those of you, like I said, you've been coming to class every time, you've been turning in your assignments. You're fine, no worries. If you're in the uh, 80s or 90s% for your grade, you're totally fine. Okay, so okay, cool. So. Uh, we are going to jump into chapter 8 review, which is on page 434. Okay, page 434, and here it is. So similar to other worksheets, gonna give you some hints, and then we'll stop the recording and we'll fill out all the answers in the worksheet. And we should probably be done a little early today. So, chapter 8 review is all about um, uh, distributions of samples. Okay, so uh, if you have a population and you take a sample from that, what does the resulting mean look like? This is where we start talking about the central limit theorem. And the central limit theorem is is a complicated concept, okay? But it's one of the very important foundations of statistics. Just like, if we were in a geometry class, like one of the, you know, main things that you need to know is like the Pythagorean theorem, like a squared plus b squared equals c squared. Like that's, so important to any geometry, trigonometry, anything like that. Same thing is true here with the central limit theorem in statistics. Okay. Um, okay, cool. So, uh, question number one, fill in the table with all of these symbols. We've seen all of these symbols before, so this one's a little bit more of a review. But you'll find this information on page 5, page 61, page 68, page 168. By the way, out of these symbols, there's 1, 2, 3, 4, 5, 6, 7, 8, and there's 8 boxes here, so there's no repeats. Okay, so everything should get used. Um, Following figures show 4 distributions. One distribution is the population. So this is our population. You'll notice that this population is skewed left. Okay. So that means that if I was going to measure the center, I wouldn't want to use the mean. I'd want to use the median. Okay. Because it's skewed. Um, so the thing is, though, if you take a sample from this population, and then you take another sample and you take another sample. You take a whole bunch of samples and you plot where the mean lands for all of those samples. You're going to get a shape that is normal, okay? That's symmetric, okay? That's the what we're talking about with the central limit theorem and the standard error and all these different things is you might have a population that is skewed. It's not normal. It's not symmetric. But when you take a whole bunch of samples, those samples create a normal distribution, okay, which is pretty cool, okay? So anyway, uh, if I take a sample and take another sample and so I keep going, I need to make sure my sample sizes are all the same when I do that. I have my mean and my population standard deviation, okay? And when I do a bunch of samples, I'm going to get the same mean for those. Okay, that's why you'll notice that the center of these curves is all right about the same. Okay, you don't have one that's shifted over here and one that's shifted over here. Okay. Um, the more samples that you take, the smaller your spread is going to be. Okay, the more accurate you're going to be. So you want to take samples that have large sizes, and that's part of the central limit theorem is you get these shapes only these normal distributions only if your samples are big enough. Okay. Um, okay. So anyway, where would I find information on how to answer this? You find this on page 165 in your course pack. You can get answers on how to, or some hints on how to answer this. Okay. Down here, what's the center? So the center has a uh, specific symbol called mu sub x bar. Okay, whatever that means. Page 166, we talk about that. Okay, for this one, for part B and C. Okay, this means the population mean using sample means. Okay. All right. Last one is the standard error. So the standard error has the symbol SE of X. So standard error of X. Okay. Oh, X bar, sorry. X bar. X bar is sample mean. Okay. Um, and we want to find that for the graph with the smallest amount of spread. Smallest amount of spread is this guy. Okay. So this one right here, because it's the skinniest, right? If we want a large spread, we want something that's wide. Okay. Usually you want a small spread. Okay. Okay. So next page is page 435. And for this one, Calculate the standard error. And again, there's a formula for that. Okay. SE X bar. Okay. And the formula for that is on page 166. Okay. It's not a complicated formula. It's you take uh, your uh, standard deviation and you divide by the square root of n. Okay. All right. So then, all right, here we go. Central limit theorem. I mentioned it a second ago. So there's three conditions that you need to satisfy in order to use it. Okay. Just like, earlier I mentioned a squared plus b squared equals c squared. A squared plus b squared equals c squared. It's a famous theorem, Pythagorean theorem. But you can't use it on everything. You can only use it on right triangles. Okay. So same thing here. You can't use the central limit theorem whenever you want. Okay. There's specific conditions you have to follow. So the first is it has to be random. Okay. Your samples have to be random. Your samples have to be independent. And your samples have to be normal. Okay. So how do I tell whether this example here satisfies those? You can find that information on page 166. There's an example for you on page 167. Okay. All right. So describe the sampling distribution of the sample mean. Okay. So we want to know the shape. We want to know the center. Okay. And the center is going to be mu sub x bar. Okay. And we want to know the spread. Okay. And the spread is the standard error. Okay. Again, you'll find that on page 166 in your course pack. And there's another example for you also on page 167. Okay. The example for this one is example E. The example for this one is example F. Cool. All right. All right. All right. Next page is page 436. And I'm not going to give you any hints on this one. Uh, you guys can figure that one out. Okay. So, last one is page 437. So the n equal this, p equal this, assume a random independent samples drawn, compute the standard error of p. Now, earlier I mentioned a second ago, we had the standard error of x bar. Now we're looking at standard error of p hat. Okay, so there's been two different types of basically two different concepts that we've been talking about in the statistics class. One is around means, and the other is around probabilities. Okay. And we're going to continue doing that throughout the course, where sometimes we're going to be talking about means, and sometimes we're going to be talking about probabilities. And that's partly because both of those can use the central limit theorem and can, follow uh, these formulas pretty closely. So there's no point in having two different courses talking about, here's what you do when you have means, here's what you do when you have proportions. We're just going to talk about them in this class. Now, that said, you have to be able to keep them separate in your mind so that you can keep track of what's what. Okay. So the standard error equation is going to be the same regardless of whether you're talking about means or proportions. It's just that sometimes when we're talking about like a proportion or a binomial distribution or something that has successes and failures, like you remember talking about that in previous courses, right? Or sorry, in previous chapters, chapter 6, we talked about that stuff. Sometimes we have the mean, okay, and the standard deviation. Sometimes we have to compute it, okay? So there was a formula for the standard deviation when you have a binomial experiment or distribution, right? It was square root of PQ, right? Okay, so if we're doing P hat, I have to do this, okay? Now, these two square roots, you can combine them, okay? But that's the idea, okay? All right. Uh, Down here, verify the conditions of the central limit theorem for proportions are met, okay? So the same thing, we need to, uh, oh, sorry. Um, so the same thing here, I need to make sure that it is random, independent, and normal. Okay. And so for independent, for example, I need my uh, mean. Okay. If I was doing means, this is an example where I'm not doing means, I'm doing proportions. Okay. So it's very similar, just a slight difference. So keep that in mind. Okay. And then down here, describe the sampling distribution. Same thing. We want to talk about the shape, the center, and the spread. Okay. All right, so that's all the hints I'm gonna give you for now. So make sure you get chapter 8 review worksheet finished before Wednesday. Uh, or sorry, today's Wednesday, before Monday. Um, Try to watch the 9.1 lecture notes before tomorrow if you can. If not, they're due on Monday. And everybody have a good 4th of July. I'm going to stop the recording and we're going to fill out the worksheet.